Hello, this is Farhan Shakil from the Republic 2.0, and I'm back with the part 2 of the 24th Edexcel paper. This is 8MAO/01 paper of May 2020 for the latest paper that we've got for level 3 GCE Pearson Edexcel. In the last video, we've completed all the questions up till question number 4, and now we'll restart all those things from question number 5, right? In the question number 5, the question says that the curve C1 has equation y is equals to 6 upon x plus 3. We need to sketch C1 stating the coordinates of any points where the curve cuts the coordinate axis and state the equation of any asymptote to the curve. So first of all, what we're going to do, we need to calculate we've got equation, and the given equation is something like, and we have got an equation, and somehow the given equation looks like that we've got y is equals to 6 upon x plus 3. So this reciprocal curve would be intersecting the x coordinate. We can calculate the x coordinate by just plugging in y is equals to 0. And I would have 6x plus 3, 6 upon x plus 3. And that's going to give me 6 upon x equals to negative 3. So 6 upon negative 3 equals to x. And I would have the final value of x, that is going to be negative 2, right? Now I'm just going to draw a graph of this function. So we know that this is a reciprocal function, and how the reciprocal function would look like. First of all, since 6 is positive, it must lie in the first and in the third quadrant, and it must be intercepting at negative 2. For example, this is negative 2. So we would have a curve like this, and then we would have a curve like this, right? And that is going to be the intercept, and the intercept of this equation is going to be y is equals to 3, right? That is going to be the asymptote of this curve. In the B part of that question, show that C1 and C2 intersect when 3x cubed minus 4x squared minus 13x minus 6. So you've got C2 as well, and that is y is equals to 3x squared minus 4x minus 10. Both of these curves must be intersecting when you'd be having this equation. So we're just going to keep them equal, and we'll simplify to see if you're having the right answer or not. So for the B part, we just need to equate both the equations. So I'll be having 6 upon x plus 3 equals to 3x squared minus 4x minus 10. And you need to move this 3 to the other side, and you would have 6 upon x equals to 3x squared negative 4x negative 10 negative 3. And then I would have 6 upon x equals to 3x squared negative 4x negative 13. And at the end of the day, I'm just going to multiply x on both the sides, and I would have 6 is equals to 3x cubed negative 4x squared negative 13x. And at the end of the day, we can rewrite this equation to look like 3x cubed negative 4x squared negative 13x negative 6 equals to 0. And that was the equation required, right? But in the C part of the same question, they're asking us that use algebra to find the x coordinates of the other points of intersection between C1 and C2. So x coordinate of one point of the intersection is negative 2 by 3. So what does that mean? That one of the x coordinate is negative 2 by 3 and 3x positive 2. What does that mean? That 3x positive 2 is going to be the factor of this equation. So I'm just going to divide this 3x plus 2 by this one, and I'll get myself a quadratic divider, and that is, easily solvable. So I'm just gonna, for the C part, I'm just gonna write that since 3x plus 2 is a factor, so by inspection, so if I do the inspection of the other things, I would have 3x plus 2 over here, and I'm just going to divide it by the thing that has been given, and that is 3x cubed negative 4x squared negative 13x negative 6. 3x times by 3x squared, I'm going to multiply 3x by x, and that's going to give me 3x cubed. X times 2 has to be Sorry, this should have been x square. X square times 3x has to be 3x cube. X square times 2 has to be positive 2x cube. And by just subtracting them up, this one and this one cancelled out, and I would be having negative 6x cube, negative 13x, negative 6. And now I'm going to times this 3x by negative 2x. Uh, Sorry, it is going to be square now. I'm just going to multiply that 3x by negative 2x to get myself the other answer. And I would have negative 6x square and negative 4x. So we're just going to change their signs. This and this going to cancel up. And I would have negative 13x plus 4x, which is going to be negative 9x, negative 6. And I'm going to times it by negative 3. And that is going to be negative 9x, negative 6. After changing their signs, they would eventually got cancelled up. So what does that mean? That the expression we had was 3x cubed minus 4x square minus 13x minus 6 would be equal to 3x plus 2 times by the divider, that is x square minus 2x minus 3. Now I just can open it up, factorize it a bit. X square minus 2x minus 3 can be written as x minus 3 times x minus 1. So the factors of x, this is what we were given with, and the other coordinates of x where those two curves are going to intersect is going to be 3 and x equals to 1. So these are the other coordinates of x. So that is how we were supposed to do the question number 5. Now we have got this question number 6. And in question number 6, he says that the binomial expansion of 1 plus ax to the power of 12 up to the and including the term x square is 1 minus 15 by 2 x is 1 minus 15 by 2 x. So we just need to expand this one, keep it equal to this one. By comparison, we'll get ourselves the value of a, and by comparison, we'll also get k as well, right? So for the a part, I'm just going to keep 1 plus ax to the power of 12, and I'm just going to keep it equal to 1 negative 15 by 2x plus kx square. And I'm just going to simplify this thingy. So 1 plus ax to the power of 12. So, if you just simply think about the binomial expansion, it has to be 12c0 times 1 to the power of 12 times ax to the power of 0, right? Plus 12c1 times a to the power of 11 times ax to the power of 1 plus 12c2 1 to the power of 10 times ax to the power of 2, and I'm going to keep it equal to 1 negative 15 by 2 x plus kx square, right? By simplifying it down, I would be having, 12c0 times 1 to the power of 12 times ax to the power of 0 should give me 1. And after this is 1, I'll be having plus 12ax, and then this thing is going to give me 66 a square x square. I'm going to keep it equal to 1 negative 15 by 2 x plus kx square. Now comparing the coefficients of x on both the sides. So by comparing the coefficients of x on both the sides, I would have 12a equals to 15 minus 15 divided by 2. And that's going to give me a is equals to negative 15 divided by 2 times 12, which at the end of the day going to give me, um, minus 5 upon 8. And similarly for the C part, for the B part, since I'm looking for the K, I'm just going to equate this K against 66a square. So K is equals to 66a square. I'm just going to plug in the value of a square, which is going to be negative 5 by 8 square. And by just sorting it out, I would just be having, by just sorting it out, I would just be having 82 point. So by just multiplying them up, I'll be having 825 divided by 32. That is the value of K, right? And now in the C part, he's just asking us to estimate the value of 17 by 6 to the power of 12. What does that mean? We just need to keep it equals to 17 by 16. What does that mean? 1 plus ax was 1 minus 5 by 8 times x. We're just going to keep it equal to 17 by 16 first of all, and calculate the value of x. And you're going to solve it down. You would be having 1 negative 17 by 16 equals to 5 upon 8x. And by sorting it down, you will be having negative 1 upon 16 equals to 5 by 8x, and x would be negative 1 by 10. So you just need to plug x is equal to negative 1 by 10 to get yourself the final answer. So first of all, the expansion of 1, since it was plus ax and a was negative 5 by 8, so it would be negative 5 by 8x to the power of 12. It would be equal to, if I just write it down again, I would just be having 1 um, minus 15 upon 2. What was that? 15 upon 2x plus kx square. 15 upon 2x plus kx square. What is the value of k? K is 825 divided by 32 times x square. Got it, Ji? So you'll have this value, right? And what I'm going to do after this thing, I'm just going to plug 1 minus 5 by 8 times negative 1 by 10 to the power of 12, 1 minus 15 by 2 times negative 1 by 10, plus 825 divided by 32 times negative 1 by 10 to the power of 2, right? And after solving it down, I'll be having 1 plus 5 upon 80, which is 1 upon 16, of course. And you'll be having 1 plus 15 upon 20 plus 825 divided by 32 times 1 by 100. So by solving it down, this thingy, you would be having 17 upon 16 to the power of 12, and you can keep it equal to this thingy, and your final answer is going to be 2.0078. That is going to be the final answer. Is that clear? Now we'll get to the question number 7. We've got log 10p versus x, and a chimney emits smoke particles on a particular day. The concentration of smoke particles in the air emitted by this chimney, parts per million, is measured at various distance x kilometer from the chimney. Show the sketch of the linear relationship between log 10p and x that is used to model this situation. The line passed through the point 0.3, 0.3.3 and the 0.6 and 2.1. Find a complete equation for the model in the form of a times b raised to the power of x. So we just need to find out the complete model for this equation, like in this form, where a and b are the constants, and give the value of a and the value of b each to 4 significant figures, right? So we have to just solve it down. So first of all, if you look back into the graph, this one, you've got an intercept that is 3.3 and that is log 10p. Since we'll need to look for the value, so first of all, we need to get 3.3's, we need to get the value of p from 3.3. So I'm just going to write that model down. So you would be having log 10p is equals to 3.3. And after that thingy, I'm just going to work out the value of p, and p should be 10 raised to the power of 3.3. And everybody knows that 10 raised to the power of 3.3 has to be 1995. So the above model can be rewritten as 1995 equals to a times b raised to the power of x. Now, if you go back to the above graph, you can see that at x is equals to 0, we can calculate the value of at x is equals to 0. We can calculate a. So at x is equals to 0, you would be having 19995 equals to ab to the power of 0. B raised to the power of 0 has to be 1. So a comes out to be 9995. That is the value of a. So now the above expression would look like p is equals to 1995 b raised to the power of x. And now what I can do, I can just simply plug in any of the points given, and I've been given with the other point, that is 6 and 2.1. I'm just going to plug that point in. So the value of P, the value of P is 6 and 2.1. So log AP is 2.1. So P has to be 10 to the power of 2.2. So you've got P and you've got X as well. So just plug them in and you would be having P is 10 raised to the power of 2.1, 1995. B is unknown and it is raised to the power of 6. So by just solving it down, dividing both the sides by 1995 and then taking the sixth root of this expression, you'll be having B is equals to 0.6310. So your model would become P is equals to A, which is 995 times 0.6310 to the power of X, right? So that is how you're going to get yourself the function. And for the B part, you just need to multiply them up and you'll get the final answer. If you want to get AB, 1995 times 0.6310. Just write the answer up till the 4 significant figures. Now we'll get to this question number 8, and we have got the straight line and this curve. And in this question, he says that you've got a curve, you've got a straight line. Using calculus, that is very important. Using calculus, find that the x coordinate of A is 2. We need to find out the x coordinate of A is 2, which is basically a turning point in the curve, right? It's basically a turning point in the curve. So we'll solve that equation. We'll look for the turning point, and if it if it is going to be a minima, then it is going to be a minima. So first of all, I'm just going to copy that equation down. So it is given that the equation of the cubic curve was x cube minus 14x plus 23. X cube minus 14x plus 23. That is the equation of the curve, right? So since they're asking us to prove that the minimum of that cubic curve is -2, so I just need to differentiate this equation. So dy upon dx would be equal to 3x square -14. So you've got the first derivative, and to check out that whether the point 2 is a minima or a maxima, you can just calculate the second derivative as well. So d square y divided by dx square has to be 6x, right? That is going to be the 6x. And if d square y divided by dx square is 6x, what does that mean? Now plug in the point d square y divided by dx square at x is equals to 2. And it comes out to be 12, which means it is greater than 0. So 2 is a coordinate and is a minima, right? It is going to be a minima. So hence verify that 2 is the x coordinate of that function. Is that clear? Now, you've got the B part and verify that x coordinate. We do not need to use calculus now. So we just need to point out the x coordinate of B is -4. So you can see that B is the point of intersection of the curve and the straight line. So we're just going to equate them up, solve them up simultaneously, and I'll get myself the values of x. And I'm just going to prove both the sides, right? So for the B part, I'm just going to equate the above given two equations, which were x cubed -14x plus 23 equals to -2x plus 7. I'm just going to solve it down, and I would have x cubed -14x plus 23 plus 2x -7 equals to 0. So x cubed and -12x, then 23 minus 7 has to be 16 equals to 0. So if 4 is a point, if 4 is a, sorry, -4 is a point, it must satisfy the above equation. That is for true. It must satisfy the above equation. And if it must satisfy the above equation, I'm just going to plug it in. 4 cube minus 12 times 4 plus 16 must be equal to 0. -4 cube is -64. Everybody knows that. 12 times 4 has to be plus 48 plus 16. And when you're going to solve it down, you would also have 0 on the left-hand side. So what does that mean? That 0 becomes equal to 0. At the end of the day, we just need to find out the finite region bounded by C and I. Use the algebraic integration to show that the area of R is 108. So you can see that the curve is lying above the line. What does that mean? Whenever you're looking for such line, the area of bounding is in between the curve and the line. So we just need to write an expression showing that the curve taken away by the line within the limits of 2 and -4 should give you 108. So I'm just going to write that area down. And for the C part, I must be having the integration between 2 and -4. And you've got the two functions, which are x cubed -14x plus 23 minus -2x plus 7 times dx. So you would be having 2 and -4 x cubed -14x plus 23 plus 2x -7 into dx, right? And I would have 2 and -4. So the final function would eventually become x cubed minus 12x plus 16 times dx, right? So I'm just going to integration with all of these things, right? So x cubed -12x positive 16 in between 2 and -4. I'm just going to plug in the limits. And after plugging in the limits, you'll see that you will have 108 units as the final answer for the area, right? Now, in the question number 9, we've got P, that is log A6, and we've got Q, that is log A25, and we need to get the values of the A part, P part, and the C part in terms of P and Q. So for the A part, everybody knows that log A256 can be written as log A16 square, which is also equals to 2 log A16, and log A16 can be easily seen. It is going to be 2 times P. For the B part, you've got log A100 and log A100. How can you write log A100 as a multiple of something like 16 and 25? So when you're looking for log A100, you can just simply write it down like log A100 can be written as 25 times 4, which is going to give you log A25 plus log A4, right? Plus log A4. Log A25 is going to be Q, and log A4 can be written as log A16 to the power of 1 by 2. And log A16 is P. So it must be Q plus half of log A16, that is going to be P. So that is how you're going to go for the B part. Similarly, for the C part, you'll be having log A80 plus log A3.2, and you just need to work it out. So log 80, if I'm sure, log 80 can be written as 16 times 5. And log 3.2 can be further written as log A 32 divided by 10. So from here you would be having log A16 plus log A5 multiplied by log A. 32 upon 10 can also be written as 16 upon, what do you call it? 16 upon 5. So it must be log A16, right? And minus log A5, right? 32 upon 10 is 16 upon 5. So now I'm just going to work it out. Log A16 is P, and log A5 can be written as log A25 to the power of 1 by 2. And then log A16 comes as it is. And log A5 can again be written as log A25 to the power of 1 by 2, which would give you P plus half of Q, and then P minus half of Q. At the end of the day, that is going to be P square negative 1 by 4 Q square. So that is going to be the final answer for the C part. Okay, so that is fine for the third part of this paper. I'll get back to you guys with the last part of this paper. Thank you very much.